Hey guys, in this video I wrap up the build of my radar-triggered garage lamp, but before doing so let me summarize and clarify the build, as I found my previous video pretty much lacking in this. I hope that the current one is a little bit better. Let's see. So the story is that my garage lamp broke down, and after removing the old sensor, replacing the LED driver circuit and making a cable SE that can switch grid power using a digital input, I had a lamp that could easily be turned on by pulling the digital input down. The next step was to prepare an HB100 Doppler radar sensor, which would output a signal of which the frequency is proportional to speed and the amplitude would depend on distance. Since this sensor outputs only a very small signal, I made an amplification board that would go right on the back of the radar sensor to prevent signal loss. This assembly, so radar sensor and amplification board, I put in a 3D printed housing and mounted together with the lamp on the outside of my garage. The cable SE I mounted on the inside of my garage. To interface the amplified radar sensor with the cable SE, I made an interface board. This interface board would do the following. It would use the amplified radar signal to detect motion. It would keep the lamp on for some time after motion has been detected. It would detect when it's dark outside. And it would turn the system on when it's dark and off when it's light. To detect motion, I thresholded the amplified radar sensor using an upper and lower threshold. I then filtered the resulting output using a low-pass filter, of which I could set the cutoff frequency. This filtered signal I would then threshold again to get a digital signal. The result was a motion detector, of which I could set the sensitivity. To keep the lamp on for some time, I used a 555 timer in monostable mode and added a transistor to reset the timing intermediately. I used a pot meter to control the on time. As for the dark detector, I used an LDR in a bridge of wheatstone, and I buffered the output of the bridge using voltage follower, and I implemented a comparator that included a deadband to prevent crosstalk between the lamp and the dark detector. To turn the system on when it's dark and off when it's light, I used a Darlington transistor array in a small and easy to use package, which could switch sufficient power. Put together, it made this board. However, I ran into one final problem, and that was that the amplified radar module would be very sensitive to noise in the power supply. Switching the relay on would cause a jump of 50 millivolts in the power supply, and this would be sufficient to send the amplified radar sensor go AWOL. Lowering the motion detector sensitivity solved the problem, but this also limited the functional range of the sensitivity setting, and so I ended up using two separate power supplies. One to supply the radar sensor and interface board, and the other to supply the relay. And after this the problem was solved. Here's a demonstration of the functional system. The motion detector I can set from detecting any tiny motion to detect almost nothing and anything in between. The on-time circuit also works. I can set it from too short to way too long. The deadband I can set just large enough to prevent crosstalk between the dark detector and the lamp, but I can also overdo it, keeping the system off all the time. As for the dark detection itself, this setting unfortunately has too little reach. I cannot set it to detect darker than this, and this is not really dark enough to my flavor. I should have chosen the resistors in the wheatstone bridge better. I actually should have measured the LDR's resistance in situ during dusk or dawn, and then used this resistance for the resistors in the bridge. I might do this later. For now, at least the system turns on and it seems to work okay. So that was about it. I hope you liked this summary and clarification, and I hope to see you in the next video. Goodbye guys.